If x is distributed normally with a mean of 10 and a standard deviation of 2.3, find these probabilities. So remember, just in case you're not sure how I'm getting that, any normal distribution, you define it with the mean mu, that's the 10, and the variance, which is sigma squared, standard deviation squared. The variance is written as 2.3 squared, meaning that the standard deviation is 2.3. So we have x is distributed normally, 10, 2.3 squared, and we need to find some probabilities. And we need to illustrate them, which means you draw a little sketch, which you get a lot of wiggle room on, but certain things you have to get right, which I will make sure I explain when the time comes. So if we find the probability x is between 8 and 11. Right, so for a continuous variable, the first thing, the fact that it says greater than or equal to 8, less than or equal to 11, is irrelevant. For a continuous variable, the lines are so thin they don't make any difference. You think if it's greater than or equal to 8, it could be 8, it could be 8.00002. It's not like a discrete variable, which might arise in a Poisson distribution or binomial, where this would mean 8 or 9 or 10 or 11. It's not like that. It's anywhere between 8 or 11, and it can be any range of values at all. So if these didn't have the little equals bit, it would not change the answer. Right, so we go to the calculator. We need to be in stat mode and distribution. So stat mode number 2. Need to be on distribution and norm for normal. And this NPD you're never really going to use. You're certainly going to use NCD today for everything, and you use this inverse normal very soon, but not today. But I will show you very soon. So for NCD, that's the cumulative distribution. It tells you the area under the curve. The normal distribution function is incredibly difficult, if not impossible, to integrate with the skills that you have. So you need to use the technology for these things. All right, NCD. And then if you look at it, so we need to make sure it looks like this. If you go to it and it looks like that, something that looks very strange, you just need to put it in variable mode, press the var for variable. And then it's a very simple thing to use. You just need a lower and an upper. Well, the lower is 8, the upper is 11, upper bound is 11, and you just need to put in sigma and mu. Sigma is 2.3. and mu is 10. Okay, execute, and that gives me some numbers. So the P is the probability. These Z's are standardized values, which again I will come to in the very near future, but I'm not going to, for now, just ignore these today. I'm just interested in the probability. So the answer needs to be given to 3 significant figures. It's 0.476. Equals 0.476, but we need to illustrate. So when it says illustrate, it means you get a nice normal curve, something like that. You can draw your mean, which is at 10, and then we're finding out the probability it's between 8 and 11. Well, if you think about it, if standard deviation is 2.3, so 8 is a bit less than 2, it's going to be probably around here somewhere, because it's less than 1 standard deviation below the mean, so we'll say that is 8 there. 11 is going to be even closer, so probably more like there, something like that. And we're finding this area like that. So if we just sort of shade it, so that's showing, you need to basically show that you know that 8's up to the left of the mean, and you wouldn't want it to be too far away, but you might even get away with it. And 11's to the right of the mean. You need to shade it, and then you need to recognize that you know that this 0.476 represents an area. Right? It's an area there, 0.476. It's actually 47.6% of the total area under this curve. Right, we will move on to B. Put it here. Now we're finding the probability x is less than or equal to 12. Like that. So we go back to the calculator. it's already where we want, but now you still have to put in a low. You know the upper value is going to be 12, right? But what you don't know is what you're going to use for a lower tail. It's certainly not 8. Now, what you need to do, just make sure your lower tail is outside of the range. And if you cast your mind back, we know that you have, I think, 99.7% of all the values are within 3 standard deviations of the mean. So make sure you're over 3 standard deviations away. And it's actually, rather than just thinking about, well, what's 3 standard deviations, just make sure you're a long way past. So 0 would be over 3 standard deviations away, but if you really want to be sure, just make it negative something, I don't know, -10, something like that. So if I put in a lower value of -10, that will make sure that my lower tail is way outside. So let me just, if I draw it on its own, it might be easier to use. Something like that. So as I say, we've got the mean here of 10. 12 is just a bit less than 1 standard deviation away, so it's probably there. Now we're interested in this area here, and you just need to make sure your left tail is way off here. So if I made it 0, it would probably be okay, but if I just make it -10, it would definitely be okay. So click, and that gives me a probability of 0.8077, so we'll call that 0.808. 0.808, and remember, recognize that that is the area, 0.808, and it's 80.8% of the total area under that curve. Right, part C, probability x is greater than 9. So I think I will draw it first. So, nice curve, something like that. Mean of 10. 9, well, you know, standard deviation is 2.3, so 9 is actually not that far to the left, so it's probably going to be somewhere like here. That can be 9. And you're interested in x being greater than. Remember, the actual being on the line, not being on the line, doesn't make any difference for a continuous variable, because it's just this thin slither of line. It really doesn't make a difference. So that's the area we're interested in. And so you're going to go back to your bit. You're going to make the lower tail 9. And the upper tail, you need to make sure it's off the range. So just make it really big. Just make it 100. It's quicker to make it something outrageously big than to actually think, well, what's 4 standard deviations above the mean? What's 5? It's not going to make a difference to your answer. So if I just make this really big, 100, click through, and that gives me a probability of 0.668. Which means, for illustration purposes, this area is 0.668.